All right, thank you everybody for joining. This is the Southern California sector-specific drought outlook, and today's date is January 22nd of 2026. This presentation is part of our effort to modernize drought early warning, where our vision is drought resilience for the nation's economic sectors. And we're going to do so by delivering sector-specific drought scenarios based on integrated and tailored monitoring and forecasting information that meets the needs of our partners, and we co-develop these processes here. The sectors that we're focusing on is agriculture, water utilities, and public health. And we do this in the context of the entire southwestern United States, as we appreciate how Southern California is tied into the hydroclimate of the region. As part of this effort, we provide monthly briefings, and they can be found at the QR code below and on this slide. Today is the 22nd of January, and we'll continue this effort throughout California's wet season and into the Northern Hemisphere summer of this year. So the next briefing will be held on the 26th of February, a little over a month from now. So the sector-specific briefing will follow this format. I'll provide a global perspective where we'll discuss global conditions relevant to the Southern California sectors. And then we'll get into a regional perspective where we will discuss Southwest US conditions relevant to the Southern California sectors. And then finally, in the third part of the presentation, we'll provide the sector-specific drought outlook, focusing on water utilities, public health, and agriculture. We have several lines of evidence here, and they're as follows. So we'll be using observed conditions, the current state of the region from observations as of this morning, January 22nd at 10 a.m. Pacific time, unless indicated. For monitoring, we use our expert interpretation of recent drought evolution that may describe many facets of drought. And then finally, predictions and predictability, expert interpretation of many types of forecasts to anticipate the future. So a forecast is a prediction, and it differs from predictability in the sense that we use our best assessment to describe and discuss and anticipate conditions to come and our confidence in them. Now, when it comes to the sector-specific perspectives, questions, we are trying to engage our partners here who are part of this effort and part of this presentation here. So what questions do you have about drought? What topics are you considering regarding drought and its cascading effects? What would you like to learn more about? And what do you think we should learn more about in order to provide more useful and powerful sector-specific scenarios? When we provide a sector-specific scenario, we provide a confidence statement. We provide a high confidence, medium confidence, and low confidence statement. And what that means is provided here on the slide. Now, as we move through the presentation here, this is the global perspective. I'll pause when we finish every section to ask if there are questions. And folks may come in and jump on the line, or they could potentially ask questions in the chat box, which I'm able to see in the moment. So, all right, let's move into the global perspective here. And where we tend to start out is with the behavior of the El Nino Southern Oscillation. It is composed of El Nino, La Nina neutral phases, and it's related to weather anomalies across the globe. Because of its slow persistence, generally across many months and seasons, we use the El Nino Southern Oscillation as a way to predict conditions in Southern California and the Southwest United States during many following months. The next part here is that the ongoing La Nina is forecast to end in early 2026, and ENSO neutral is forecast in spring 2026, which is then followed by increased chances of El Nino in summer of 2026. So La Nina increases the chances for below average Southwest US precipitation. It hasn't really done so here for Southern California, but that tends to be an outlier, and we'll describe that a little bit more in the following here. If we were to look at El Nino here, El Nino would generally provide opposing patterns with some small nuance here, but just to get to the heart of the point, why we care about La Nina is because of its relationship with drier conditions generally in the Southwest, as well as warmer conditions as well. So the El Nino Southern Oscillation is monitored and measured in several different ways. The easiest way, and probably the most widespread way of looking at the El Nino Southern Oscillation, is looking at sea surface temperature anomalies, that's departures from average, in the central tropical Pacific Ocean. There's several areas that we use, and one, and probably the most popular, is the Niño 3.4 region. That is used to compute the relative oceanic Niño index. What that simply means is that we take 3-month averages of the departures from average of Niño 3.4 index, and we plot it like so here on the screen, and that's plotted in the black curve. Now, within that, we've shaded this curve here for the departures that exceed minus 0.5 and 0.5 degrees Celsius from the average. And you can see that here on the curve. So where we are right now is with an ongoing La Nina event, and that began in August of 2025. And you can see that right here. It's a pretty weak event. It's on the heels of an event last year where we had a La Nina event, which itself was pretty weak as well. If you look at this in a longer term context, you'll note that since about 2000, we've had many more La Nina events than we have El Nino events. And that really is the behavior of the tropical Pacific itself, but also this relative index takes into account Pacific or tropical sea surface temperature departures from average too. Now, there are many possible outcomes in the spring to summer 2026 ENSO forecast. What the chart here shows is that relative index, Nino 3.4 index here on the vertical curve, the vertical aspect of this plot. And on the horizontal, this is time, beginning in January and moving all the way through June. As we can see here, the forecasts from these individual models indicate a transition from La Nina to ENSO neutral and suggesting a El Nino event as we move to later in this year. Now, these forecasts are used by operational forecasters like our partners at the Climate Prediction Center, and they put together these forecasts here and make an official NOAA forecast of El Nino, La Nina, and ENSO neutral, and that's what's being shown here. So the percent chance of La Nina neutral and El Nino is shown in these blue, gray, and red bars respectively as a function of time. And these are provided in 3-month seasons, December, January, February, March, all the way to August, September, October. As you can see here, the chances of La Nina decrease as we move into spring and through summer. And the chances of neutral ENSO conditions, they are predominant throughout the springtime in the Northern Hemisphere. And that includes February, March, and April, May, and April, May, June. Now, as we move to later in this calendar year, the middle of the calendar year, that is, during summertime, there's an expectation that El Nino has an increased odds or chance of occurring. So this situation of the El Nino Southern Oscillation is very dynamic, and so dynamic that we need to really follow this as we move through this 2025-2026 period. Now, the regional perspective is as follows, and then I'll pause after the regional perspective for any questions that everyone may have. So in terms of the current drought, this is a very dynamic situation. Southern California is actually free of drought due to several heavy precipitation events since November of 2025. Heavy precipitation during La Nina events is not a likely outcome, though it remains possible. This year is an example, but other years in the last decade include 2016 to 2017 and 2021 to 2022. And then finally, areas in the Southwest United States that supply water to Southern California remain in drought due to low water volumes and snowpack. That is a principal highlight of this presentation and certainly the biggest hazard that we're seeing right now. As of January 20th, 2026, this is the U.S. drought monitor. As you can see throughout Southern California and all the counties that we are considering here, that there is no drought coverage over these counties. And this has actually not been a really prevalent feature over the last 5 to 6 years. As you can see here, we were in drought as of October of this year. And because of the sequence of heavy precipitation since that time, drought has been ameliorated. But you can look back to other periods as well and see that drought was really prevalent in the last 5 to 6 years. Now, highlighting the southwestern United States, there's drought really overspreading much of the region and some of these key areas that supply water to, say, the Colorado River. And that has relevance to Southern California. So the upper Colorado River Basin is in exceptional and extreme drought, and other areas of the Southwest as well, like Utah, New Mexico, and Arizona. Now, we've had a wet start to the 2025 to 2026 water year in Southern California. On the left is precipitation. This is in units of millimeters. In the center column here, this is the precipitation percentile rank over the same period, and that period being the 1st of October to the 18th of January 2026. Looking at this center panel here, you can see that across almost all of central and southern and towards Southern California, that precipitation is in the upper 20th percentile of a historical distribution that includes years from 1991 to 2020. And there are some of these areas here in which we have seen the wettest such period on record, again, compared to 1991 to 2020. Unfortunately, that's not quite the case in some other areas of the Southwest. This includes parts of Nevada, Utah, and the all-important Upper Colorado River Basin, so western Colorado, eastern Utah, and even down into New Mexico and Arizona. Now, one cautionary tale that we do want to throw out there is that just because you had heavy precipitation through mid-January, it doesn't necessarily indicate a good water year in some locations. So if we were to end the water year right now, and if it weren't to rain from now all the way through September 30th, what you'd note here is that across almost the entire region, precipitation would be the lowest on record, with the exception of those areas in Southern California where we've seen heavy precipitation to date. So some of these areas really include some coastal areas and inland as well. But just because we've had copious precipitation through mid-January, it doesn't necessarily indicate a good water year in some, if not most, locations across the general region. So more precipitation is needed in the Southwest. Now, to further flesh this out, what we're showing here is precipitation in units of millimeters on the vertical axis, and the horizontal axis begins on October 1, this is time, and extends all the way to September 30th of the following year. The black curve on here shows 25 to 2026, and the coloring shows the precipitation percentile rank compared to a period of 1991 to 2020. This year has been characterized by two very wet periods, one in the middle of November and the other the last week of December and early January, where you can see that those two periods provided almost the entirety of precipitation during this 2025-2026 period. And in the middle of that, a dry period in which no precipitation was observed in Southern California. So all told, where we stand over Southern California in an average sense is in the upper 20th percentile of the historical distribution. Now let's compare this to last year. A lot of similarities with last year in terms of La Nina and what we had expected, at least ahead of this water year. So 2024, 2025, we were carving out near record lows as of the 18th of January, compared to this year where we're really at the top end of the historical distribution. So during the La Nina, you can have some wildly different outcomes. And the wildly different outcomes in 2025 and 2026 and 2024 and 2025 are pretty apparent here. Now, if one were to go and pull all of the La Nina events since 1950, this is what all these lines look like. They represent all the La Nina events since 1950. And what you'll find here is that for the most part, you tend to see below average precipitation in Southern California. However, you can see these heavy precipitation years, this one included, but also times like 2021, 2022, and 2016, 2017. So heavy precipitation during La Nina is possible. It is not a likely outcome for Southern California and for the southwestern United States. And this year was certainly an outlier in that sense. Despite the heavy precipitation in Southern California, snowwater volumes in the southwestern United States are really pitiful right now. You see these values that are less than 50% of the median across almost the entirety of the Southwest, perhaps with the exception of areas further to the north where conditions are at least a little bit closer to the average, but certainly not high enough, at least for this point of the year. Some of the Sierras are actually seeing above average snowwater volumes, but we do use caution here because some of these areas, only one station is contributing to the basins that are included here. So it's probably not a very complete sampling here, but nonetheless, because of the heavy precipitation that we did see in parts of Central and Southern California along the Sierra, there are some above average conditions, but not to take away from the really dour situation that we're seeing right now over the Southwest. And we'll get into that a little bit more as we move through the presentation. Now, as we move into forecasts relevant to drought, there's no significant precipitation events forecast over Southern California through at least the first week of February of 2026. The second point here is that above average temperatures and below average precipitation are forecast for the remainder of the wet season in Southern California from February to April of 2026. And then finally, above average temperatures are forecast in May to July of 2026, the beginning of the dry season in Southern California. This chart right here is a really useful one to be able to anticipate some of the principal drivers of precipitation in Southern California and generally in the Western United States. And this is monitoring incoming atmospheric rivers from forecasts that are based on the GEFS model. So the United States weather forecast model, for lack of a better term. So what's being shown here is on the vertical axis is latitude, and these latitude lines correspond to the Western United States. And on the horizontal axis, what we're seeing here is time from the beginning of the forecast. So time being 0, this forecast was initialized or began on Thursday, the 22nd, today at 6Z. And what we find here is looking at the probability of integrated vapor transport greater than a certain value. So basically the coloring here indicates seeing integrated vapor transport that is noteworthy along the Western United States, and that value is 250 kilograms per meter per second. And what we find here throughout all of Southern California, which is nominally north of 30 degrees and south of about 35, 36 degrees, is that there's very little chance of seeing noteworthy integrated vapor transport, which would be a bringer or a harbinger of precipitation in Southern California. So we're not anticipating any significant precipitation events in Southern California through at least the first week of February of 2026. And this forecast goes through the 7th of February, 2026. Now, another line of evidence here is that we do need precipitation in the southwestern United States in order to make up for these significant deficits that we have seen here. So as a line of evidence here, what we've done is to take precipitation from the 1st of October to the 18th of January, and then take into account all historical seasons in the record that we have, which dates back to 1951. What we do is we take that observed precipitation to date. We then take precipitation for the rest of the water year. So from the 19th of January all the way to September 30. And then we calculated the chances and the frequency in which we see below average precipitation on the left, in the middle, near average precipitation, and on the right, above average precipitation. So just starting here on the right-hand plot with the greens and the blues, what this is indicating here is that based on historical conditions, all the historical conditions we have in precipitation to date, there's a very high likelihood of above average precipitation in Southern California and all the counties that we are considering here. On the other hand, looking at much of the rest of the southwestern United States, and of course, the all-important Colorado River Basin, precipitation to date, combined with all historical seasons, indicate a very high likelihood of below average precipitation to the end of the water year in September, at September 30. That is real cause for concern because this is a place right now where we do need some recovery in terms of the amount of precipitation that falls and specifically the amount of snow that falls as well. Unfortunately, precipitation and temperature forecasts for the remainder of the Southern California and Southwestern winter wet season, they are not optimistic. So on the left, these are from colleagues at the NOAA Climate Prediction Center. This is a precipitation outlook, and these are probabilistic. So deeper brown colors indicate a higher likelihood of below average precipitation. And on the other hand, deeper green colors indicate a higher likelihood of above average precipitation. Same conventions here on the right with seasonal temperatures. Deeper red colors indicate higher chances of above average temperatures, and deeper blue colors, which really don't prevail on the map, indicating higher likelihoods of below average temperatures. So in the Southwest, and specifically Southern California, there's an increased likelihood of below average precipitation and above average temperatures. And that's not a good situation for the general southwestern United States because of the really poor start to the precipitation thus far. As we move to May to July of 2026, so really the beginning of the dry season in Southern California, indicating above average temperatures are most likely. So following the same conventions from the NOAA Climate Prediction Center forecast, above average temperatures are most likely in the Southwest, and not seeing much of a tilt in the odds to below average precipitation or above average precipitation. And that's generally the case just because it's the dry season there. So that finishes up our assessment of the state of the Earth system and also regional behavior. Are there any comments or questions from our participants? Okay, well, hearing none, we will move on to each of the sectors that we are focusing on here, really focusing on conditions to date and forecasts. So here is the scenario that we have created for water utilities. Reservoir storage and groundwater levels are expected to be average or above average in Southern California through 2026. We have high confidence in that. We also have high confidence in that low inflows into Lake Powell from the Colorado River are expected this year, which could impact future water supply. We have several lines of supporting evidence. There are average and above average reservoir levels and groundwater levels in California after above average precipitation since November of 2025. There's low snow water volume and snowpack across the southwestern US as of the 21st of January of 2026. Below average precipitation and above average temperatures are forecast for the remainder of the ongoing wet season in the Southwest. And then finally, the Bureau of Reclamation projects lower inflows into Lake Powell in the next 2 years based on the most probable model outcomes. So we'll begin here with the California Water Watch and its depiction of reservoirs as of the 21st of January. And in Southern California, we're seeing conditions that are indicating a very high reservoir levels as a departure as a percent of average. Some of these reservoir levels are at about 200% of average because of the heavy precipitation that was observed. And this is generally the case elsewhere in Southern California. And the same is really applied here to the rest of California as well. Much of the same in terms of groundwater levels, though there are some mixed conditions the further away from the coast that you go. This applies for both Southern California and for Central California too. Now, really the big story here is the snowpack in the Western United States, and specifically the Southwestern United States. So just to summarize from what I said before, below average snow water volumes are prevalent across much of the Southwest, and they continue to decline. So as you can see over the Southwest, conditions from USDA's NRCS indicate 50% of the median value across almost the entirety of the Southwest and even into other parts of the West as well. And one area to note here is in part of the Central Sierra. There is one station that's reporting 128% of average, and this is why that basin right there is lit up as it is. Now, just to further flesh this out a little bit more, this is snow water volume in the upper Colorado region. So this is where my cursor is being highlighted right here. And what we're finding here is that we are seeing the record low value for snow water volumes as of January 22nd for the current year 2026. And that's depicted right here in the black line. So the vertical axis here shows snow water volumes, and the horizontal axis here indicates time, beginning on October 1 and then extending all the way through the water year, ending on September 30. So as you can see, this black line really has not shown much of an increase through time. Now, comparing this to the historical distribution of values during 1991 to 2020, you'll note here that the value is carving out a record low compared to that period, and that conditions continue to worsen as we haven't seen much precipitation over the Southwest over the last 2 weeks. Now, really where we should stand right now, at least in a median sense, is a snow water volume that is not quite twice as high as where we are right now, but we're about 34% of the of conditions where we should be to date, and carving out the record low value. Now, one thing too, if you're looking for silver linings here, one thing to be optimistic about is that there is a long way to go left in the season. And we typically don't see peak snow water volumes until about the 1st of April. It's sort of a magic date in the Western United States that everyone looks to as being all important for water resources. There's a long way to go to there, and we can see some recovery. And usually this time of year, we're seeing that recovery. Some recovery is possible, but forecasts that I showed previously in terms of precipitation and temperature, they aren't encouraging. And I just wanted to highlight 2 years on this chart right here, in addition to the current year that we're in, which is shown in black. The red curve right here is 2021. What you'll note here is that 2021 is actually at a similar value today as it was in 2021 is a similar value as today. What you can see is that there was considerable recovery during that year. You can find that recovery by April 1 was actually closer to the average. And then there are other years like 2024, where we were somewhat similar to the trace during 2025 and 2026 as of the early January. And that value actually overshot the median value for that year. So some recovery is possible, but unfortunately forecasts for this year are not encouraging. Now, this is from the Bureau of Reclamation. And what they do is they project out lake levels in Lake Powell to some future date. And they made this projection here in January of 2026 from baseline conditions or starting conditions in 2025. What they do is they take conditions for that month, December of 2025, and then they include all historical years, and then they are able to produce this spread and the possible outcomes. The most probable outcome here is the middle of that distribution. It's shown here in the green curve. And what it indicates is an inflow to Lake Powell with a release of 7.48 million acre feet in 2026 and 7 million acre feet in water year 2027. That most probable outcome really only shows a tiny little increase compared to where we are now. And that increase tends to happen in May and June as we're seeing a lot of that those water volumes in snow being released because of warming temperatures. So not expecting too much of a bump in the springtime for this year. There are some more dour situations. This first one here is the red curve. This red curve is the probable minimum inflow. And what that includes is the lowest of all of the years, including all of the years with current conditions. So this is what the lowest value we would expect to be. So these will probably fall somewhere in here. And what we note here is a very minimal bump in this spring and then falling lake levels in Lake Powell as we move through summer of 2026 into winter of 2026 until perhaps some recovery in the spring of 2027. So decreasing water levels generally to spring of 2027 are anticipated based on conditions to date and historical conditions that have been used to produce this scenario. So that finishes up our water utility scenario and also the lines of evidence. Are there any comments or questions from those participating?
I keep waiting for the good news.
I knew you'd say that, Roger. Yes, I don't think that there's any good news. Trying to be as comprehensive as we can and look at silver linings, but there isn't much of a silver lining. Roger, do you have anything else that you'd like to add?
Well, I guess it's a similar question that I probably ask every time is, are you getting reached out to? Well, maybe put it this way, are any water utilities reaching out to you for this information, or maybe anybody on the call about this information and what they could or should be doing?
This may be a question for Amanda. Amanda, I don't mean to put you on the spot here.
We can punt this for like the end after the recording to save some time, but not so much right now given conditions and some of these things and the unknown for some of the policy.
Okay, I got a couple other kind of questions, but I can wait till the end.
Okay, thanks, Roger. Okay, so we will move on from water utilities and revisit this in a little bit and move on here to public health, where heavy precipitation following drought really leads to a very dynamic situation. And we'll try to illustrate this here as best as we can. Number one, poor air quality due to blowing dust in Southern California is expected from March to June of 2026. We're highly confident in that. Valley fever cases are expected to rise in spring, summer, and autumn of 2026, given the recent heavy precipitation following drought and the normal spring winds that we tend to see in the region. High confidence in that. And then finally, there's a low risk of poor air quality from wildland fire smoke through spring 2026 due to recent precipitation. High confidence. The supporting evidence here is increased airborne dust is expected due to intermittent winds in spring of 2026. Heavy precipitation following drought will allow the valley fever fungus to thrive. And then finally, the risk of significant wildland fire potential in Southern California through spring 2026 is normal. So this is air quality as we stand today. And what you can see during most mornings in Southern California is that air quality tends to lead to unhealthy for sensitive groups, though there is some day-to-day variation. So if you were to look at this yesterday, you'd actually see a better depiction of air quality compared to when this was pulled this morning after 7 o'clock a.m. Pacific time. There is a normal significant wildland fire potential forecast for early 2026 due to the early wet season start. And this is from the National Interagency Fire Center Predictive Services. And what they do is they assign above, below, and normal significant wildland fire potential for these individual administrative units within the Geographic Area Coordination Center regions that are highlighted here in the dark black coloring. So you can see that for Southern California and the southwestern United States, that there is a normal significant wildland fire potential. This could be updated as we move through January into February and into March. And the reason for this is because the southwestern United States, their peak fire season is in northern hemisphere spring. So April, May, and into June. If conditions continue to be as dry as they are right now with warm temperatures, it would stand to reason that significant wildland fire potential would be above normal in the Southwest. And because of that, that could have implications for air quality for Southern California. This is not reflected in the forecast that was released at the beginning of January, so January 2nd of 2026. But this is something that will have to be closely monitored given the evolution of the weather over the last few months and the expected evolution of the weather over the next few months. Now, where we stand right now is we saw heavy precipitation following drought. On the right, I showed this map previously where we had drought conditions in Southern California as of October, but drought was ameliorated within the local region because of the heavy precipitation beginning in November, but that precipitation then becoming heavy once again at the end of December and early January. That precipitation has the potential to really affect fungi in the land surface and in the soils. And this is something that has been documented pretty well in the literature. And as a result of that, when the soils do begin to dry out, as they typically do in the springtime, combining this with the climatological winds, this can lead to valley fever and increased incidences of that. Now, kind of doubling back and to highlight the drying of the soils, above average temperatures and below average precipitation are forecast for February to April. These conditions would really prime the pump for drying out those soils, with the valley fever fungus now becoming more prevalent and allowing that fungus to then blow around. Now, speaking of blowing around, this is Southern California daily average wind speed beginning in October and moving all the way through the water year beginning on September 30th. This is on the horizontal axis. The vertical axis indicates wind speed, and this is shown in terms of a distribution as a percentile rank from 1951 to 2023. So when comparing this distribution of wind speeds through time, what we note here is that the distribution begins to bump up and increase, and really indicating an increase in the amount of wind speed and windy days that can happen during April, May, and June. So this increase in the wind that we tend to see for this time of year, that's Northern Hemisphere spring, combined with the normal drying of the land surface in which the valley fever fungi is able to thrive because of heavy precipitation following drought, this would lead to a situation where we need to have a heightened situational awareness. So that finishes up our public health scenario and the evidence for that. Are there any comments or questions? Okay, well, I don't see any in the chat, and I'd just like to thank our California Department of Public Health representatives, because they've been great partners, and we hope to continue that relationship beyond this presentation. Okay, moving on here to agriculture. I would say this is probably the most optimistic of all of the scenarios that we provide, and this is just based on precipitation that has fallen locally in Southern California. So we're expecting high agricultural productivity based on above average precipitation and average evaporative demand since November of 2025. We have high confidence in that. We also have high confidence in crop stress, and that's expected from February of 2026 through spring of 2026 due to below average precipitation and above average evaporative demand. The supporting evidence is that there was above average precipitation and below average evaporative demand between November of 2025 and January of 2026. There was above average soil moisture as of mid-January 2026, and that below average precipitation and above average temperatures are forecast between February and April of 2026. Above average temperature forecast suggests an above average evaporative demand forecast. This chart right here is from Leslie Roach, and what it indicates on the vertical axis is the growth rate of annual rangeland forage production, and on the horizontal axis it indicates time beginning in October and then going through the following 12 months. What we find here is that from October to February, there's some growth rate, but that growth rate really increases in March, April, May, and in June. What we would expect here is, because of the above average precipitation and wet land surface, this would really help to support plant growth and forage production growth rate. This is further supported here by soil moisture anomalies. This is shown as a percent of average, and just comparing the September 15th, where we were when we were in the throes of drought, to January 15th, when we certainly are not in Southern California. So in Southern California, soil moisture was very much below average at that time, and now it's very much above average because of some heavy precipitation episodes. One thing that I do want to call out and note is Nevada, Utah, Arizona, and Colorado. The reason is this perspective would make it look as though soil moisture is in a much better place today than it was on September 15th. I don't think this is the case. The reason for this is because many of these areas should actually have snow on the ground, thus insulating the land surface from having any increases in soil moisture. The fact that soil moisture has increased considerably over this region, despite the fact that we've seen below average precipitation, would really highlight that we have a land surface that is getting a little bit more water than it should at this time of year, just because the ground is not frozen and just because we have not really built up that snowpack in the land surface. So I don't think we should be interpreting this pattern right here as being a really good situation for the southwestern United States. I won't belabor the point on this, but we do want to highlight that we saw copious precipitation from the 1st of October to the 18th of January, essentially because of those two precipitation episodes, one in the middle of January, one in the middle of November, and one in the end of December and the beginning of January. So that copious precipitation really leading to those good agricultural conditions and outcomes. We talk a lot about evaporative demand, and this here is the evaporative demand drought index. So you can imagine this being the thirst of the atmosphere, where when we're seeing these warm colors, yellows through reds, it means the atmosphere is thirstier, meaning it's robbing the land surface of moisture more than it otherwise would. And by contrast, these are wetness categories. And what they indicate is that when we are on the wetter end, the atmosphere is not as thirsty, meaning it is not demanding as much moisture from the land surface as it otherwise would. And over Southern California, this is not a pattern that we see very often, but seeing wetness categories that are pretty considerable here, in the sense that we are seeing conditions that are not robbing the land surface of its moisture, that being also from plant transpiration. So conditions have actually been very good for agriculture in Southern California, all things considered, because of the demand of moisture by the atmosphere and also because of the precipitation that's making its way into the land surface. On the other hand, below average precipitation and above average temperatures are forecast for February to April of 2026. And that right there would put some stress on crops and on any vegetation that is at the land surface. So that's something that should be noted here. So despite the fact that we would expect some increased agricultural yields relative to average just because of the precipitation and evaporative demand we've seen so far, conditions for the next 3 months are not so favorable. And here again is the agriculture scenario, and I'd invite anybody to make some comments and ask some questions if they have any.
Annie, go ahead. You raised your hand.
Thanks. This is not a fully fleshed out thought, but I was wondering if you have insights into like how much crop stress we would have to observe before we saw impacts on farm worker job security.
That's an excellent question. I'm probably not in a great position to answer it right now, but it's something that we could potentially look into. Do you have any insights into that? Is that something that you have any information about?
I haven't looked too much into it. That was sort of why I asked, but I think it just ties, this agriculture scenario to public health impacts because we know farm workers are probably a population facing greater vulnerability and with, less job security. And so it would be something we would want to know more about.
Yeah, that's fascinating. I think what we probably need to do is to find some statistics on job security, whether it's employed or unemployed folks, and try to map them to different situations related to drought, pluvial, and try to make an assessment that way.
Yeah, I think it would be great if we could try to explore this a little further, or maybe try to tie in maybe what we're seeing with crop insurance payouts or something else. I know Shibayu's on the call, and I think he had an idea to look at crop insurance payouts to try to assess public health impacts.
That's very interesting. Shibai, I hate to put you on the spot. Do you have any thoughts on that?
I think he unmuted himself, but I don't know that we can hear him.
Yeah. Well, Shibai, perhaps we can follow up by email because it doesn't seem like we can hear you speaking.